So let's do number 40 in 10.1. We've got f of x is the cube root of x minus 4. Cool. And then they ask us to complete a table, graph the thing, think about the domain. Okay. Table. Right? First things first, maybe? Okay. Can we fill in the table?
Yeah.
Okay, so I want to think about where negative 4 goes as an input, right? Okay, so I put it in for the x here. And so I'm going to get, let's see, cube root of negative 4 minus 4. That's the cube root of negative 8. Gives you negative 2. Do I need to worry about the negatives here?
No. Because it's an odd.
Yeah, this is an odd root, right? So I'm not worried about signage. Signage only concerns me when I have even roots, right? Okay, so that seems fine. How about when I put 3 in, what do I get?
Negative 1.
We get negative 1 in there. Cube root of negative 1 is
Negative 1.
still negative 1. Okay, how about when you put 4 in?
0.
Get cube root of 0,
0.
which is 0. How about when you put 5 in? Get 1 out. And 12, 2. Oh, that's funny. Look, we didn't start with our 5 favorite points, but we ended, or 5 favorite numbers, but we ended with them.
Oh, yeah.
Okay, how about graphing this? Can I graph this? Yeah, I could throw the points on a graph and connect them. Okay, so there's supposed to be, let's see, I need up to negative 4 and 1, positive 12. So what do you do with these?
Negative 4, negative 2.
Okay, so I need to go left 4, down 2. Then I need to go left,
Right.
oh, right, 3,
3 out. Down 1.
down 1. Then what else?
Right. 4, 0.
4, 0,
5, 1.
5, 1,
And 12, 2.
and 12, 2. I made a really stupid choice here. You guys see what the really dumb choice I made was? For some reason, I chose to smash all of this stuff into this itty-bitty little corridor. Right?
Yeah, you could have made it.
I could have made it wider. Yeah, I think it still gets my, oh, new tooth. I think it still gets the point across-ish, right? But it's a little bit smush. So what should this thing look like? It should be a little sideways whoopty thing. There's that one. Okay, so it looks roughly like this, right? Really roughly. How else could I have gotten that picture instead of connecting the dots?
Just knowing your lot, your constant stuff.
Easier. Look at this thing. It's a cube root, so it's a whoop-de-doo. And it's got a x minus 4 put in it, which is a shift to the right by 4. So I can take my standard whoop-de-doo and shift it right 4. You guys see that?
Yeah.
Okay. So all the way to come up with this. How about the domain? Negative infinity to infinity? This? How else could you phrase that? Okay, the big R, or you could write out the phrase all real numbers.
Symbol with the leg.
Yes. A paragraph symbol with a leg. Cool.
I don't know. Better.
No, it's good. Okay, so how else could I have determined that? Where did I get these from? Where did you guys get these?
Where it goes negative and where it goes positive.
No, this would be even easier. Here, I just want to ask myself, what kind of stuff can I fit into F, right? So what kind of numbers can I subtract 4 from? Are there any restrictions on subtracting 4? No, so I can subtract 4 from all the numbers, right? Can I cube root all the numbers? Yeah. So neither of these functions has a domain problem. So I can fit whatever I want in here. That's telling me I should get all of R. You guys see how I kind of didn't need the picture to do that? Where else could I get the graph? If I was struggling with connecting the dots or thinking about shifts, what's your go-to tool? Yeah, graphing calculator, Google it. Google it probably won't work, but Wolfram Alpha will. Google it might work. Cool. Questions, things? Cube roots are easier than square roots, right?